So cosine is always even, tangent is always odd, the whole thing is odd, so the answer is 0. But I have to write y. So odd function and symmetric interval. Just writing 0 is not good enough. Please.
So
Yes.
what would make a function odd?
A piece that is odd and everything else that is even. So a product of an odd and even always gives us an odd.
Jeff, how do you know 10 is odd?
Because there are only two trigonometric functions that are even. Cosecant and the other function that has, cosine and the other function that has only cosine in it, which is secant. No other trig function is even.
Except the square.
Just two even functions. Cosine and the other one that has only cosine in it, which is 1 over secant. 1 over cosine, which is secant.
So if it's sine squared, is
If,
that
sine squared is a different story. Sine squared is even. But sine alone, very good question. Thank you.
Is it because
Sine alone is odd. Tangent alone is odd, but tangent squared is even.
is it because it's tan squared and the sine squared are both sine times sine, which is odd times odd?
Correct. So only cosine and secant are even. Everything else is odd. However, tangent squared is even. Sine squared is even. Good. Next integral, please.
Look at B.
Yes, let's do B. Okay. Let's look at B. B as in boy, right? Very good. So we have the integral from 0 to 4 from 1 over the square root of 1 minus x squared dx. What will you say about this? It's a definite integral, so I have to check whether the function is continuous. But the function is not continuous. Can you give an example where it's not continuous? At 1 it's not continuous. What about at 4? It doesn't even exist also, right? Because it's 1 minus 16, which is a negative number. So I will say FTC, is not applicable. F of x undefined on 0, 4. You don't have to mention where. That's good enough. You correctly identify the fact that it was not continuous.
And then can we do D?
D as in dog.
Yeah.
Very good. Let's look at D. The integral from 1 over x squared sine 1 over x dx. Perfect. So what do you recommend with this one? We recommend what? Yes. So let's say let y be 1 over x. Very good. You can use any substitution you want. Doesn't have to be u or y. You can use t, you can use w, you can use z, whatever you want. Very good. So only if dy is in the problem or easily makeable. Is dy in the problem? And remember, dy is not the derivative, but the differential of the function, y. So what we get? Negative 1 over x squared times? Indeed. No, not a problem. That's not a problem. Multiplying by -1 twice gives us exactly what we want. So now let's change the whole thing into minus outside, and please tell me what will you write inside. You will write,
Sine u.
yes, that's fine. He may have used u, that's fine too. Which function prime is sine u or sine y?
Cosine.
But cosine prime is not sine y, but negative plus a constant c, which turns to be positive. So I have cosine 1 over x plus a constant c. So remember, when we differentiate cosine, we don't get sine. Or you can incorporate the negative and say that it's cosine. Same thing. And then we have to go back to the substitution because this is an indefinite integral, and we have to give the answer using the variable given in the problem. Yes, next question. C. Very good. We have the integral from arctangent to the 5th power, everything divided by 1 plus x squared dx. So what do you think?
Right, would be arctangent.
Yes, of course. It's arctangent inside power 5, of course. So let's say let t be arctangent x only if dt is easily makeable. Because if you need to make up an x or a t or a 5t cubed, it's not going to work. So what do we have? 1 over 1 plus x squared, of course dx, and this is what I have here. So then what is the integral? And of course dt this time. Yes, t to the 5th. That's it. Which is t to the 6th over 6 plus a constant c. But I have to go back and change it to 1/6 arctangent x to the 6th plus a constant c. Anything else?
So for E, you just multiply by 2.
Let's take a look. E, yes. So what I would do with E, because the function is what? It is even. Awesome. So thank you. The integral from -3 to 3 from an even function is not 0. I know you know that. I'm just saying it. So it's easier always to do this. Always. Because if the lower limit is 0, I don't have to plug it in. So this is 2x to the 5th over 5 plus x cubed over 3 from 0 to 3. It's sufficient that I have to plug in 3 in all this, but it's nice that I don't have to plug in -3. So 2 to 5th times 3 to the 4th is 81, and 81 times 3 is 243, I think, plus 27 over 3. So, so 486 over 5 plus, that's 9. So 486 times 45. No, not times, but plus. So 2 times, what is this? Okay, 1062 over 5. Yes, please.
If it was like that example, it's 2x4. What was 2x4 plus 2x plus x3? Could you
No.
break it up in 2?
No.
Break it up in 2.
Here, there is
Ignore
no
that
need.
one.
There is no need. There is no need to break it up in 2. You can.
We just ignore the
So let's take a look. Just make sure that I understood your question correctly. So I think you're saying that what happens if I have the integral from negative 3 to 3 from 2x to the 4th plus x cubed?
we just ignore it.
So you want to change it into from negative 3 to 0 and from 0 to 3?
No, what I'm saying is if you were to break that up into 2 like that, using properties, could you just ignore the x cubed because it's not calculate that?
You could. Yes, you could. And that would be 0. I see what you mean, yes. So that will turn into the integral from negative 3 to 3 to 2x to the 4th dx. And then you will have still 2, the integral from 0 to 3 from 2x to the 4th dx. And you will have 4, the integral from 0 to 3 from x to the 4th dx. Yes. I see now. Very good, yes. Good. Next question. Uh, 56 on 414. I was just looking at it. The integral from 0 to 3 from dx over 5x plus 1. The function is not defined at negative 1/5, but negative 1/5 is not between 0 and 3, so this is safe. So how do I continue? Of course. So dt equals 5 dx. That's not a big deal. Multiplying and dividing by 5 will not change anything. This is 1. Do not copy the limits of integration, and please tell me 1/5 in front. What do you have now? Inside first. Inside we have dt over t. And now the limits of integration, please. When x is 0, how much is t? Perfect. When x is 3, how much is t? Excellent. So finally 1/5. What function prime is 1 over t? And there is only one? Very good. Natural log the absolute value of t from 1 to 16. So now finally I realize that the absolute value for this problem is redundant. So this is 1/5 natural log 16. Because when I subtract natural log 1, I get natural log 1 is? Thank you. Good. Next question. If we don't have anything else from here, can we go back and start reviewing for the final, or you don't want to do that yet? We have 3 more meetings left. Monday, the following Monday, after Thanksgiving, and Wednesday. So Monday we have to review for the final exam. The test will be a week from Monday. I have to grade it and return it on Wednesday, when we have a second session of reviewing for the final exam. I'm not going to review chapter 5 anymore. So I have to go back to the other ones, 2, 3, and 4. Unless you have questions, of course, then I will have to review or answer your questions. Yes. Is there anything else that you want to go back to?
What, 131, 417?
417. Very good. 417, number 31. 416, 417, I found it. 31. So the integral from tangent x, natural log of cosine x dx. Well done. Great job. Tangent x times natural log cosine x. Okay, what do you think? Well, our first thought, don't write it just yet, we're talking about it. First thought would be cosine x, right? But then du equals negative sine x dx, which is not bad, because I know tangent is sine over cosine. And this is natural log cosine x, right? So I have in the denominator u, I have natural log u, and I have the du. So this is our first option. But I'm thinking of a second option. I don't know if it works, but I want to present it to you. Yes, this is what I think. But I have to check. Okay, so then du will be 1 over cosine x times the inner function prime, negative sine x as a product, careful, times dx. Oh, but this is du equals negative tangent x dx. And I'm in business. It's okay to give it a shot, right? In this case, there are potentially 2 options. And we do have 2 options. They both work, right? But I think the second one is much more elegant, if you want. We'll get the same answer. So if I denote this composite function with natural log inside it, with cosine inside natural log, then when I differentiate natural log, I have 1 over the function, 1 over cosine, times the inner function prime, which is negative sine, times dx. And that whole thing is du equals negative tangent x dx. So all this is du. And this, nice, it's just u. Very good pick. Thank you, Felix. So this is negative the integral from u du. It can be nicer. So negative the integral from u du, which is negative u squared over 2, and I have to go back. Plus a constant c. And do not forget the constant c, please. So now I have to plug in, instead of u, I plug in natural log. So negative 1/2 natural log of cosine x, everything squared plus a constant c. Well done.
So
Yes?
the packet number 6, can we do something similar to that?
6, number 6. You mean for the total distance?
Yes.
No. You have to find the absolute value of the function and split it up into pieces. Yeah. Very good question. No. Not possible. Anything else? Which one? Yes. So it says find the general indefinite integral, which is the antiderivative, illustrated by graphing several members of the family on the same screen. So we can do that too. So we are given the integral, the indefinite integral from cosine x plus 1/2 x dx. Excellent. And I guess they're asking us to choose which one it is. Okay, very good. Thank you. Perfect. So let's find the most general antiderivative, or the family of functions. Which function prime is cosine? Right, plus 1/2 x squared over 2 plus a constant c. So we have sine x plus 1/4 x squared plus a constant c. And we want to graph a few. I'm going to say c equals -4, c equals -3, c equals -2, c equals -1, c equals 0, c equals 1, c equals 2, as many as you want. C equals 3, c equals 4. Whatever the calculator allows me to. So let's see. Let's go to the graphing calculator. Very good question, very good problem. Thank you. So y equals, clear whatever you have. I can only plug in, I guess it will allow me 7. So I'm going to choose 6. So I'm only going to use, or 6 or 7, right? So just these, from -3 to +3, including 0. So ready? Very interesting problem. I love it. Make sure that your mode is in radian mode. Make sure of that. Perfect. So y equals sine x, close the parenthesis, and then plus 0.25 x squared. And we said we start at -3. Okay. The next one. Same thing. Sine x plus 0.25 x squared and -2. And the next one, sine x plus 0.25 x squared. I see. Plus 0.25 x squared and -1. Okay, next one, sine x plus 0.25 x squared. Next one, sine x. I think it's enough, or we should continue with more. Plus 0.25 x squared plus 1. Is that good enough? And now I'm going to hit enter or zoom 6 and see what happens. Here is the first one with -3. Here's the next one with -2 in it. Here is the next one with -1 in it. Then the one with 0 in it after this. You have your functions. They all differ by a constant. In this case, they differ by 1. So here is the one with constant 0. And here's the next one with constant +1. C equals 1. And then the next one with 2. And I think I stopped at 2. I don't think I put the 3. I did the third one? No. That's it. Very good. Thank you for asking that. All these functions have the same derivative because they differ by a constant. And when I differentiate the constant, it will go away anyway. Very good. Thank you. Next question. Anything else? Don't forget to finish your homework so I can post the grades. Any other topic that you would like to go back to? I know you're not going to have any difficulties with this, correct? We just had one with the total distance, same idea, right? The integral from 1 to 2 plus the integral from 2 to 4. Same thing. Right? Good. Next problem.
Choose 4 and 6. Are you gonna do that?
Say it again.
You said choose. I didn't see that. You said choose 4 and 6.
4 and 6, you mean?
Choose 4 out of 6.
Oh, yeah.
Are you gonna do that for us?
Which one?
Choose 4 out of 6.
Maybe.
You can explain A, or can you just write
Which one?
for
You mean this one?
A? Yeah,
So what is the answer?
0.
0. Because there is no width.
Right. It's just a-
Just write 0.
Do we have to write an exclamation point, or can we just write?
Well, I would write that it's 0 because there is no interval. Yeah, I would write that. Anything else? Is there any other topic that you would like to go back to? Would you like me to choose?
Yes.
Can you suggest anything? I don't want to waste the time, so can you suggest anything?
So what's the integral of 1 over x squared?
The integral of 1 over x squared. Very good. It's negative 1 over x. Excellent. Let's do that. Good point. So the integral from 1 over x squared dx is the function that I differentiate to get this. Which function I differentiate to get this? It's negative 1 over x, right? Let's check, right? When you differentiate this, you get the function. When you differentiate this, you get negative 1 over x squared with minus in front. Well done. Good point. I love that. Okay, can you at least choose the topic? And then I will choose the problem. I can't think of anything that we didn't cover, but I know we need practice and I don't want to waste the time. Which one?
I'm just thinking chapter 2 is so long. We're talking about the whole course, right?
Yeah, are you saying any chapter or?
Just whatever you want me to. Are we comfortable now with test 4? I mean, you still have another week or so to review everything, but is there anything that we should work on from chapter 4 again? I'm sorry, I meant chapter 5. Yes? Or you want to go back to other chapters?
I can't think of an example, but the number 7 properties one always gets me.
Yes, let's take a look at properties. Very good. So the properties are on page 384. Page 384. And the ones that I can see here are 55 through 58. I'm looking also at, let's say, 66 is another one. I'm looking now at 59 through 64 and see what they mean with that. Yeah, those two. Yeah. So please choose anything. Which one?
No, I'm just saying somebody else choose, I can pick all of them.
Just before anyone else picks. Oh, let me show. I'm sorry, maybe you don't have the book. We looked at this one. We looked at this one, I believe, and this one also. Maybe not. I'm not sure. And yeah, you choose. Let's not spend too much time on choosing, though. You want to work on 58? Okay, 58. On page 384. And they say the square root of 2 pi over 24. They say less than or equal to the integral from pi over 6 to pi over 4 from cosine x dx. Less than or equal to the square root of 3 pi over 24. Now you could say, I don't need to choose any properties here because I'm very able to determine the integral from cosine x. It's sine x from pi over 6 to pi over 4, and I'm done. We're not asked to do that though. We're asked to show using properties that integral is a number between the left number and the right number. Where is my starting point? Always with x, indeed. That's all I know, that x is a number between pi over 6, or an angle in other words, between pi over 6 and pi over 4. But now I have to be very careful. What will be my next step? My next step is to apply what to all three sides? Right, but I can't. Not before some analysis. Exactly, because cosine is a decreasing function. So this is pi over 2, and this is pi over 4, and this is pi over 6. And cosine does this. At pi over 6 is a bigger number than at pi over 4, and then smaller and smaller and smaller. So applying cosine, since it is a decreasing function, it changes the inequality symbols to the reverse, because cosine pi over 4 is smaller than cosine pi over 6. So I can no longer copy this because cosine is a decreasing function. I have to copy this. So that's why I kept going back to the function and showing you the function and so on and so forth. Now I can write this inequality from here. Cosine pi over 4 less than or equal to cosine x less than or equal to cosine pi over 6. How much is cosine pi over 4? So that's the square root of 2 over 2 less than or equal to cosine x less than or equal to, what is this? Very good. Once we establish that, the problem is almost finished, right? What do I have to do to all three sides now? Because now I have three functions, right? One here, and one here. The area under the first one must be smaller than the area under the second one, must be smaller than the area under the third. By that I mean the integral. dx, of course, from pi over 6 to pi over 4, all of them. That's the integral, that's where we are looking. The middle one is done. I don't have to do anything. It's what I needed to have in the middle. But now, this is the square root of 3 over 2. Which function prime is 1? Because this is outside. Which function prime is 1? X. From pi over 6 to pi over 4. I take the square root of 2 over 2 outside. Which function prime is 1? From pi over 6 to pi over 4. So fundamental theorem of calculus part 2 allows us to find this. In other words, the square root of 2 over 2. And in parentheses, pi over 4 minus pi over 6. Less than or equal to the middle, pi over 6, pi over 4. Less than or equal to the square root of 3 over 2, pi over 4 minus pi over 6. But how much is pi over 4 minus pi over 6? I need the least common denominator. I need to multiply this by 3, and I need to multiply this by 2. So 3 pi minus 2 pi is pi. So pi the square root of 2 over 2 times 12, less than or equal to pi over 6 to pi over 4, from cosine x dx, less than or equal to, and I get the same thing, it's pi over 12, right? So the square root of 3, so pi, the square root of 3 divided by 24. And this becomes 24. And that's exactly what they wanted. They wanted us not to calculate the integral, but to show that it's between the square root of 2 pi over 24 and the square root of 3 pi over 24. That's all we needed to show. Questions? Okay, next topic. Do we still stick with test 4? Okay, about 6-7 minutes left, so let's do something else. Unless you want the same type of problem, we can do the same type of problem.
Do the,
Yes?
on the textbook, can we do the red problem that is in those?
They what?
The, was it 57?
From the same section? Yeah, we did 57 in class together. You mean this one? Yeah, we did that, but we can do it again. I remember doing it, but maybe I'm wrong. Yes? Have we done this? Yes? Yes, okay. That's what I thought. Anything else? You want to try this one with tangent? It caught my eye. I don't know. Yes? Okay, so let's look at tangent 61 from pi over 4 to pi over 3 from tangent x. It says use property 8 to estimate the value of the integral. So property 8. Property 8 is this one that we just used. The same thing. But they are not showing us the left and right. Here we have to come up with it ourselves. Okay, so it was one more time. I just missed it. I think it was pi over, yes, it was pi over 4 to pi over 3, just making sure. So 61. Pi over 4 to pi over 3, tangent x dx. Perfect. Now, my first thought is, where do I start, of course? And secondly, to graph tangent. Very important. So pi over 4 is right in the middle, and pi over 3 is larger because pi over 4 is 45 degrees and pi over 3 is 60 degrees. Since the function is increasing, right, I'm not worried about anything. Okay, finally, where is my starting point? And now I will definitely do what? If the function is increasing, I don't have to worry about changing the inequality symbol, so I apply tangent to all three sides. So tangent pi over 4 less than or equal to tangent x less than or equal to tangent pi over 3. So in this problem, we were not given what we needed to show, so we have to start from scratch. Good. So I always tell my students, do not bother to remember or memorize tangent. Because you know for tangent pi over 4 is sine over cosine, they're both the same, this must be 1. Here we have two options, right? So if it's pi over 6, that's 1/2 over the square root of 3 over 2. But if it's pi over 3 is the reverse ratio, the square root of 3 over 2 over 1/2. So this must be the square root of 3. All we needed to know is that between pi over 4 and pi over 3, tangent, if you want, can be squeezed in a way between 1 and the square root of 3. That's all I need. And now I will apply the integral dx, of course the definite integral, from pi over 4 to pi over 3. The left-hand side is x from pi over 3 to pi over 4, so I have pi over 3 minus pi over 4 less than or equal to the integral. And then I have the square root of 3, again pi over 3 minus pi over 4, because it's x from pi over 3 to from pi over 4 to pi over 3. So the same thing here. I have the denominator is 12, so 4 minus 3 will be 1. So the left-hand side is pi over 12. And the right-hand side is the square root of 3 pi over 12. So we estimated